Write a balanced equation for the overall reaction that occurs in the cell. C₂H₅OH plus 3O2 gives 2CO2 plus 3H2O. 1 point is earned for the correct reactants and products. 1 point is earned for balancing the equation. Calculate E standard for the overall reaction that occurs in the cell. E standard equals minus 0.085 V plus 1.229 V equals plus 1.314 V. 1 point is earned for a correct answer that is consistent with the equation in part A. Calculate the charge, in coulombs, that pass through the cell. Calculate the initial C₂H₅OH in the solution. I equals Q/T. Q equals IT equals 0.10 amp 20. S equals 2.0 C. 1 point is earned for the correct charge. 2.0 C, 1 moles E minus / 96,485 C. 1 moles C₂H₅OH / 12 moles E minus is equal to 1.7 times 10 to the power negative 6 moles C₂H₅OH. 1.7 10 to the power negative 6 moles C₂H₅OH / 10.0 milliliters, 1.0 liters / 1,000 milliliters is equal to 1.7 times 10 to the power negative 4 molar. 1 point is earned for the number of moles of C₂H₅OH. 1 point is earned for the initial molarity of C₂H₅OH. Calculate the value of Cr₂O₇ at 1.50 minutes. Absorbance is proportional to Cr₂O₇. 1.0 by 10 to the power negative 3 molar / 0.782 equals X / 0.553. X is equal to 7.1 times 10 to the power negative 4 molar. Or, initial condition, A equals ABC. 0.782 equals A, 0.50 centimeters. 1.0 by 10 to the power negative 3 molar. A equals 1,564 centimeters to the power negative 1 molar to the power negative 1. At 1.50 minutes. 0.553 equals 1564 centimeters to the power negative 1 molar to the power negative 1. 0.50 centimeters, C. C is equal to 7.1 times 10 to the power negative 4 molar. 1 point is earned for the correct concentration. The student runs a second trial, but this time uses a cuvette that has a path length of 1.00 centimeters. Describe how the experimental setup should be adjusted to keep the initial absorbance at 0.782. Justify your answer with respect to the factors that influence the absorbance of a sample in a spectrophotometer. A equals ABC. If path length, B, is doubled and molar absorptivity, A, is constant, the initial concentration of Cr₂O₇, C, must be halved to keep the initial absorbance, A, constant. 1 point is earned for reference to a factor that affects absorbance. 1 point is earned for the correct adjustment. Explain how the experimental data indicate that the reaction is first order with respect to Cr₂O₇. Absorbance is proportional to concentration of Cr₂O₇. Absorbance is halved after 3.00 minutes and again after another 3.00 minutes. Thus, the half-life of the reaction is constant. So the reaction must be first order with respect to Cr₂O₇. Or, demonstration that the rate of change in ln A over time is constant. 1 point is earned for a correct explanation that uses the data.